Alright, so today we're going to talk about energy diagrams. What you have to know is that there's two types of reactions when it comes to energy. We have endothermic and we have exothermic reactions. First, we're going to talk about an endothermic reaction. An endothermic reaction absorbs energy, so that means that it takes energy in. Alright, so the energy of the product, so the product was on the right side of the equation, is greater than the reactant. So right here, this is a diagram. It's called an energy diagram. You put energy on your vertical axis, and then you see that your reactant is starting at a certain energy. Then, all throughout this line here, that shows the process of the reaction. So it's going to be increasing energy, and then we notice that our product levels off right here. If we look on our energy diagram, our product is higher up on the vertical axis for energy. That means that our product has a higher energy than our reactant. Alright, so this diagram, you're going to have to be able to recreate this diagram and know that this is an endothermic reaction because our product has more energy than our reactant. Some examples of an endothermic reactant is when ice melts or when evaporation occurs. So I know this might seem weird because you're saying that it absorbs energy, but ice melting is when it gets from cold to hot. If you think about the actual particles in water, okay? When we're in ice, we know that the particles are really, really close together. If we're melting, we're going to a liquid. When those particles are really, really close together in the ice, in order for it to get to the liquid, it has to take in more energy because those particles are going to be moving a little bit faster, and you need more energy in order to create those molecules moving faster. Now if we're talking about evaporation, we are starting with liquid, and we know that our particles are moving a little bit, but in evaporation it gets to a gas where our particles are moving all over the place. So evaporation, we're going from some movement, gaining lots and lots of energy in order to get to those particles moving all over. Alright, so the other type is an exothermic reaction. That is when energy is released. So the product has a lower amount of energy than the reactant did. So our reactant is on the left side and our product is on the right side. Right here is an energy diagram for an exothermic reaction. So this is something that you'll have to recreate as well. So here we see that our reactant is starting up here, then our reaction takes place, and when our product levels out, when it comes to the end of the reaction, we see that it has less energy than our reactant did. Some examples of this are a heat pack, alright? Another is an explosion, another one is freezing water. So let's think about the heat pack and the explosion. You're starting at right here, and then the reaction happens so that you can create heat. Heat, if you are feeling the heat that's coming off of it, that means heat is being released from the reaction, making the product have less energy because you're releasing that energy. Heat is a form of energy. Alright, in explosions, things come together and they explode, and once they explode, those particles don't have a lot of energy anymore because it took so much energy in order to create that explosion. Freezing water. So if we're going from a liquid to a solid, those particles in a liquid are moving around, and the particles in a solid are not moving, they're just vibrating. So in order to get those moving particles to slow down, you have to take away some of their energy in order to get them to slow down. So this is all you really need to know about endothermic and exothermic. Our next unit is going to deal a lot more with this stuff, but just for Unit 1, this is what you need to know. You need to know how to recreate these diagrams and know what endothermic is and what exothermic is.